Hi there, I'm Graham. I'm a low carbon energy surveyor for Octopus Energy and I specialise in heat pumps. I've done this little video to give you an idea of what's involved in an Octopus Energy heat pump survey, and I figured that if I can send this to you, explain a bit about what I've got to do, then firstly you'll understand and have questions for me which are pertinent, but also help me help you, and I'll explain some of the things that I need to look at. And why I need to look at them as well. So the first thing really is I'm going to show you, because I've just arrived in this house. I'm doing a survey in this one here, and like I chose this house because this house has got a bit of everything. So if I just show you the outside, it's bloody cold today. I need a heating engine here, don't you? Right, so firstly, this is a mixture of old and new. So the houses around here, they're all like solid stone, which makes things a bit tricky. For the reason what it means is basically the heat pump survey needs to, the first thing we've got to do is we've got to measure the heat loss of the building. So that's solid stone, and this is a cavity stone wall, and this is exactly the kind of thing that I need to measure, because the heat pump survey starts with understanding heat loss in order that we can size the machine, and a lot of the location of the machine comes down to how big it is and how much noise it will make. So that's the first thing, really. Measure the house, measure the sizes of the rooms and the sizes of the windows and the doors. We need to measure the radiators, and I need to check the insulation in the loft and things like that. I also need to measure, space available for things like the cylinder cupboard and things like that. So in order to help me get onto the to get the drawing done quickly, I'm going to ask if I can use your Wi-Fi, and by connecting my tablet to the Wi-Fi, I'll be able to draw the house on that, and then I'm going to be working from my mobile phone, looking at the radiators as well. What a smooth cut. I'm not very good at this. I'm good at heat loss calculations, but I'm not very good at. I'm not a YouTuber. Right. So I was going to sort of explain a bit about. So why do we need to upgrade radiators? Well, quite simply, the heat pump runs at a lower temperature than a typical boiler, like an oil boiler or a gas boiler. So it's the radiators that heat the room, and if they take longer to heat the room, then the heat pump's going to be running for longer. So the bottom line is, unless you upgrade your radiators, it's going to cost you more money. I'm going to do a separate video on that. So keep an eye on this channel. There's a lot more involved in that, and I'll come back to it. Not least, microbore pipework. So microbore pipework is like, so you can see that's about 8 or 10 mil. I need to check and measure that quite carefully, because any kind of pinch points on the heating system mean it will restrict the amount of heat going into the radiators, and that can affect the efficiency of the machine, and it can also be a big problem. So that's one of the things I'll be looking for. Now in this case, this room here, this has got underfloor heating, so the only part of the house that does have underfloor heating, and I need to be able to report to get the grant that the underfloor heat is going to work to basically make enough heat in this room. And how we know it does that? How can we? Well, we need to measure the pipe spacing. This is the circuit of the pipework in the floor, and if you've got drawings of it, as it was when it was installed, fantastic. If you don't have drawings of it, like this house doesn't, then what we're going to have to do is we're going to have to turn it on, and we're going to use a thermal imaging camera to measure it with a tape measure, literally measure it and work out how much heat's coming out of the floor, because it's really just a big radiator if you think about it. It's not much different to that. In this case, I'm going to show you, I'll turn the camera around. So in this house, they've got a underfloor heating manifold for this floor here in that cupboard there. Now, if I'd have known that, I would have asked the customer if they wouldn't mind clearing the space and letting me get some pictures of that, because that's really important that we can identify the number of loops and actually take pictures and document how the underfloor heating works. Because what we don't want is to put a heat pump on your house and have it not work. So that's a really important part. So if there are underfloor heating manifolds in your house, if you could clear them so I can get some pictures of that and study it, that'd be great. There's a cylinder in this house on the first floor. I'm going to do a separate video on cylinders because they're a bit fiddly, but the cylinder wants to be as close as possible to the heat pump. Now it's really complicated, so I'm going to do that in a separate video, but that's one of the places that I'm going to need to look at all the measure the pipe work, and I need to measure the space. to make sure that we can get a really well insulated cylinder in there. You might have, as the people in this house have got as well, solar thermal, and that's a whole separate video on that, because solar thermal presents complications, but nothing we can't deal with. What else we've got? So yeah, in addition to, we need to make an application to the National Grid, the DNO, always get that wrong, National Grid, so that we can put that extra load onto your fuse board. And so I'm going to need to see where the fuses are, and I'm going to need to test them. And I usually do that by putting a clamp meter on some of the cables and turning on your oven and things like that. So this is called a maximum demand test, to make sure that you've got enough capacity in your on your main fuse. And we also need to make sure you've got enough water pressure as well, because heat pumps need a certain amount of water pressure. So there's a lot involved. It takes a long time, and I enjoy it. I think it's a fantastic company to work for, Octopus, and it's always nice meeting people and finding solutions. And I'll be honest, it isn't always possible. A house like this was designed to run on coals. Also, houses are in a constant state of evolution. Really interesting how, you know, the role of houses has changed. How we now live in them is very different to how they were built. So yeah, it's a fantastic job. Your survey will be really interesting, and you know, I've got a passion for this subject, and I'm here to help you. I'm not on commission. I'm not doing it for free. I do actually get paid to do it, but I don't know, if I was a rich man, I'd probably do it for fun. It's good, and I look forward to meeting you. All right, cool.